Leaving cert higher level 2014 paper 1 question 9 is an exponential function. Y is equal to AE to the power of KT. T is time in minutes. Y is the difference between the water temperature and the room temperature in degrees Celsius. A and K are constants. The temperature of the water when it boils is 100 degrees Celsius and the room temperature is a constant 23. Part A, write down the value of the temperature difference Y when the water boils and find the value of A. Well, Y is going to be equal to the difference between the two temperatures, so Y is going to be 77. And to find A, well, A, my initial amount is always when T is equal to 0. So T is equal to 0, so 77 is equal to AE to the power of 0. So in this case, 77, e to the power of 0 is 1, so 77 is equal to A. So my function is Y is equal to 77e to the power of KT. Part B, after 5 minutes, so T is equal to 5. The temperature of the water is 88, so Y is equal to the difference between 88 and 23, which is 65. Find the value of K. Okay, so we have Y 65 is equal to 77e to the power of 5t. So 65 over 77 is equal to e to the power of 5t. So we can say we're going to get the natural log of both sides here. That I should have put k, not t. So the natural log, we could use logs, but the natural log is easier in this case. 65 over 77 is equal to 5k. So if I just divide this by 5 and cancel my 5 here, I have k. So k is equal to minus 0.03388, 0.3388, and 3 significant figures is going to be 0.339. K is equal to minus 0.0339. At this point, you could get the log of both sides. You could say the log of 65 over 77 is equal to 5k by the log of e. So to get k on its own, I need to divide by 5 log e. So the log of 65 over 77 divided by 5 times the log of e, you need to put to the power of 1 in your calculator, will give me k, and you get the same answer. So either way, natural logs are logs. Part C, Kieran prepares food for his baby when the water has cooled to 50 degrees Celsius. How long does it take correct to the nearest minute? So we need T for the water to cool to this temperature. So we need Y. Y is the difference in water temperature and room temperature. So my Y is 27. So 27 is equal to 77e to the power of minus 0.0339t. So divide by 77. 27 over 77 is equal to e to the power of minus 0.0339t. So if you get the natural log, 27 over 77, that's going to be equal to minus 0.0339t. So just dividing this by minus 0.0339 will give me my t. So t is equal to 30.9135, 30.91 to correct to the nearest minute, or yeah, nearest minute. Okay, so that's enough, 31 minutes for t. Part D, we're told to use our values for a and k. Sketch the curve f of t is equal to a to the power kt between 0 and 100 for t. So they've given us this graph 10 up to 100, so let's use all these values. So t is equal to 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And set up your calculator so we can work out what y is. We also had a 0, which we know the initial amount was 77. So you can put that on straight away, 77 up here. And then get these values. So set up your calculator and then just change the t each time. So t is 10, it's going to give me 55. When t is 20, it's going to give me 39. 30 is giving me 28. 40 is giving me 20. 50 is giving me 14. 60 is giving me 10. 70 is giving me 7. 80, it's dropping to 5. 90, it's dropping to 4, and it's slowing down. 100, it's dropping to 3. So 3, 4, 5. Let me start off with 10 now. 10 is 55. 20, 39. There's scale obviously on the diagram in the exam that you're going to be using, and you'll be more accurate than me. 30 is 28. 40 is 20. 50 is 14. 60 is 10. And now it's veering towards the x-axis. 70 is 7. So try and connect these dots. Yeah. Close enough to what would be the accurate version that you have drawn. Part E of this question, you're told or you're asked, on the same diagram, sketch a curve g of t is equal to ae to the power of mt, showing the water cooling at a faster rate, and a is the value from part A and m is a constant. Okay, so we have the same initial starting point, say here. It's going to cool faster, so it's going to come underneath the graph. So it's a sketch. Let me try and connect these lines. So faster rate coming in here underneath. Next part of this question, suggest one possible value for m and give a reason for your choice. Well, let's take a value off the curve here. This is 20 for both. So I come across here, I'll get to approximately 25. So we can say that y is equal to 25 when t is equal to 20. So we just use maths to get a value. So we can say that 25 is equal to 77 e to the power of t is 20 and m from this equation here. So 25 over 77 is equal to e to the power of 20m. So we get the natural log of 25 over 77. That's going to be equal to 20m. So if I just divide by 20, I'm going to get a value for m. And this is going to give me minus 0.056. So m is equal to minus 0.056. And what was our other value that we got up further for k? Minus 0.0339. K is equal to minus 0.0339. So you can see here that m is less than k, and it would need to be less than k for faster cooling. So we're asked to find the rates of change of the function after 1 minute and 10 minutes corrected to dp. So we have y, so let's get dy dt. dy dt. So we know from our rules of differentiation that e to the power of ax differentiates to ae to the power of ax. So I need to multiply this number here by the 77. That's going to give me a minus, and it's going to be 2.6103. I'll bring in the 03. E to the power of, and then this number doesn't change, 0339t. So that's dy dt. So I just need to put 1 in and I need to put 10 in. So at t equal 1, I'm going to get minus 2.6103 e to the power of minus 0.0339. And on a calculator, that is going to give me minus 2.52. And at t equal to 10, I'm going to get minus 2.6103 e to the power of minus 0. And the decimal will move just one place, so 0.339. And that's a minus, and that's going to give me minus 1.86, both correct to 2 decimal places. And the final part show that the rate of change of f of t will always increase over time, so we need to show that d2y dt2 is greater than 0 for it to be increasing always over time. So we have dy dt up above. You can see here it is, we're going to get a minus by a minus to give a plus here, so e to the power minus 0.0339 t. So we're going to multiply the minus 0.0339 by 2.6103 to get 0.088 e to the power of, it's not going to change, minus 0.0339 t, and that is greater than 0 for all values of t. Therefore, dy dt, which is what we have, is increasing.